Hello, my name is Manuel Navarro Catalan, and I'm here to talk to you about the model transformation for high-performing smart grid applications project. This is a joint Rensselaer Polytechnic Institute and New York Power Authority project with the teams from AlsetLab and AgileLab involved. The project is made possible through NYPA. First, I want to go through the project overview, the objectives, modeling with Modelica, the OpenIPSL library, some of the Python scripts and unit tests we have developed for the project, as well as linear regression testing, and finally, version control that we've been using throughout the project. Many companies in the power system world use tools such as P.Sc and PSCAD to model their big systems. And in this project, we want to prove that using Modelica, we can build an entire library for NYPA and New York State components and show that we can create a model such as the NYPA 500 bus in Modelica and be as good as P.Sc. We want to show users and NYPA that Modelica models give the same answer or even better answer than P.Sc. As far as the software domain goes, we want to create testing models for different testing scopes and in order for us to evaluate the developed models and technologies. We also want to create a method for software automated continuous integration and regression testing for the new models coming into the library, as well as creating Python scripts for simulation, automation, and optimization. So our deliverables would be, and objectives would be to validate the OpenIPSL models against P.Sc models, implement the missing OpenIPSL models, create a model translation tool, and recreate the NYPA 500 bus model using Modelica. The OpenIPSL library that I've been talking about is an open source Modelica library for power systems. It contains a set of power system components for phasor time domain, for modeling and simulation. And all of the models have been validated against a number of different reference tools, but we have focused mainly on P.Sc. So the advantages of OpenIPSL and Modelica is that it gives us an unambiguous model exchange. We have a formal mathematical description of the model, so it's very transparent. And we can separate the tools and the IDEs and the solvers from the tools. So now we know that you can use the tool that better fits your needs and the library without having to be tied to something specifically. And of course, the use of object-oriented paradigms. So in order to speed up all of our simulations and manage our results, we have created Python scripts that are designed to simulate all our Modelica models, our P.Sc models, export them into CSV format, and the results into CSV format in order for us to be able to validate them later using P.Sc models as a base. And for this, we've created different unit tests. So we have three different kinds of base models: generating units, shut units, and series devices. So for each of these three different types of models, we'll be creating three different types of contingencies, where it's three-phase bus fault to ground, load variation, and the step in the reference in the exciter voltage signal. So these cases will be derived from the SMIB, and these are very useful because if they're both the same in P.Sc and in Modelica, we can take that it has been validated. So in order for us to do that, we take both the P.Sc model and the OpenIPSL model, then we simulate them through Python. We select certain key variables that we want to test. We convert it into CSV. Then we perform linear regression testing, and then we can see whether it has been verified or not. The linear regression testing so for the P.Sc base signal, we take that P.Sc as a base signal, we create an upper and lower error tube, and then we plot the Modelica signal in order to see whether it's inside the error tube or not. If it's inside, then we know it's passed. If it's not, then we take it as failed and do some adjustments. As far as version control, we have been using GitHub and Git in order for us to control all of our versions of the library of the models and for all the different entities within the project to be able to work together. And finally, right now as far as the ongoing work, we are working on a model transformation tool, which we aim to automatically model from P.Sc to Modelica. We are also working on a continuous integration pipeline, which will automatically verify all of these models. And if a new model comes in, see if we should put it in, if it's good enough for us to put it in the library. And finally, an NYPA 500 bus in order to prove that implementation of a Modelica model can deliver as good results as B.Sc models. For now, that's it for our project. Thank you very much for your attention. I hope you like the presentation.